Hi everyone, hopefully you can hear me there okay. So this is just a video to go through question number 15 from your nutrient management plan assignment for your sustainable farming in the environment module. So in the first video, I went through all of the other questions in this assignment, but now we are just coming back to complete this question 15. So hopefully you can hear me okay and you can see the assignment okay. All right. So basically what we need to do, again, as I said in the first video, you need to make sure that those numbers are visible. You need to make sure that you can read them okay. So again, if you have to, just expand them out until you can read them okay. So basically here what we are looking at is the available nitrogen allowance and the available phosphorus allowance that is permitted for this farm. So basically what we're talking about here, it's given us a breakdown of all of the different uses of the land. So there is grazing ground, grazing and reseed ground, first cut and grazing, second cut and grazing, winter wheat and maize. So that's a breakdown of all of the different uses for the land in this farm. And depending on the use for each of those land types, basically our nitrogen and phosphorus allowance is going to be different. So obviously, depending on what you are growing, depending on the offtake, your requirements will either be higher or lower. So that's basically what we are looking at here. All right. So the first thing that it asks you to do, if we just scroll down, okay, so it says above are the nitrogen and phosphorus allowances for each crop for this farm. The following are the maximum chemical nitrogen and phosphorus totals allowed for the farm after the number of livestock are taken into account. So all in all, covering all of the land on this farm, the maximum amount of chemical nitrogen that can be spread is 17.5 tons. So that is the maximum amount of chemical nitrogen that is allowed to be spread. For phosphorus, then the maximum amount of phosphorus that is allowed to be spread is 1.5 tons of chemical phosphorus. So we need to make sure we will be selecting out what fertilizers and what amount of those fertilizers we are spreading. So we need to basically make sure that we are not exceeding those two figures or we would be in breach of our cross compliance. So that's really important. So if we just look there at specifically what it is asking us, so copy the totals from above into the table below, then choose suitable chemical fertilizer products for this farm and calculate the total tons for each product that are close to but under the amount allowed. All right, so what it is asking us, it gives us a breakdown. This table is just split at the minute over the 2 pages. So it is telling us the crop, it is looking for the total nitrogen, the total phosphorus, and then the chemical fertilizer products and the tons of fertilizer allowed. So those are the 4 things that it is looking for here. So the first thing that we need to do is to basically go to the grazing ground and find out what the total nitrogen and the total phosphorus are. So if we scroll back up here, we get to our grazing ground. All right. So here, this is going off. It is telling us how much ground is grazing only is 27.8 hectares. For nitrogen index 1, it is telling us that all of that land is index 1 and that the total nitrogen is 7,839.5 kilograms. All right, so 7.8 tons in that scenario. So that figure, that's 7,839.5, okay? The best place really to get that from, as opposed to here, is actually here. So this is our total nitrogen all in all, okay? Our total nitrogen recommendation for that grazing ground, 7,839.5 kilograms of nitrogen. So we scroll down and that figure should be going in there. Okay, that figure should be going into that box. We should then be doing the same for our phosphorus. Scroll up. Here's our phosphorus allowance. Come to our grazing ground As we can see, there is some ground in index 1, some ground in index 2, some ground in index 3. So again, in this scenario, the best thing to do is come to our total to get our figure, and that figure then should be popped in to this box. And that gives us our total nitrogen and total phosphorus for the grazing ground. All right. What I would recommend you do then, don't worry about the chemical fertilizer products and tons of fertilizer allowed just yet. I would recommend you then go on to the next one, grazing and reseed, come up, have a look at our figures and pop those figures in here for total nitrogen and total phosphorus for grazing and reseed, and do that the whole way down. Just complete those first 2 boxes for each of those. All right. So when you have that done, that's nice and straightforward. You're basically just taking those figures and copying them directly from the table above into the table below. That's all you're doing for that part. The next bit is a little bit trickier. We need to select, okay, so I'll just pop in. So that phosphorus figure, 735.8, okay? We now need to pick, based on the nitrogen and phosphorus requirements for that grazing ground, what chemical fertilizer products would we recommend for that grazing ground? Okay, so what chemical fertilizer products would we recommend, and how many tons of fertilizer are allowed? Okay, so just be careful there. Here we're talking about kilograms of nitrogen, kilograms of phosphorus, and here it's talking about tons of fertilizer allowed. Okay, so chemical fertilizer products that we're going to select to address this requirement, and how many tons of that fertilizer are going to be allowed. So how do we do that? How do we work that out? So the first thing that we need to do, I have just opened up a list of the Goulding's products, so different fertilizer products here. And we're going to need to know how to work out then how well those fertilizers will address the the nutrient requirements for the grazing ground. So we have a breakdown of all of these fertilizers. So these are mainly our nitrogen fertilizers down the bottom, the likes of your CAN, your urea is there. All right, those are our main nitrogen sources in terms of chemical fertilizer. So here we see the percentage of nitrogen contained in each of those fertilizers. So CAN, for example, is 27% nitrogen. When we scroll up then to the likes of our compounds, so 18612, we know 18% nitrogen, 6% phosphorus, and 12% potassium. 18% nitrogen, 6% phosphorus, 12% potassium. Okay, so here those figures give us a breakdown of the proportion of each of those nutrients that are contained in the fertilizer. So we have a huge range of fertilizer products there. Then we have the likes of our mainly phosphorus fertilizers. So these are only containing phosphorus in terms of our NPs and Ks. No nitrogen, no potassium contained in those ones. And then we also have the likes of your myriad of potash, which only contains potassium and doesn't contain any nitrogen or phosphorus. So that is the breakdown of our different fertilizer types. And then we have these ones here, which are, they are compounds, but they are nitrogen heavy. So that's a breakdown of our different products. So I'm just going to open another page here that just is going to help us outline how to calculate our fertilizer amounts. So the first thing, right, we need to be able to interpret this information. We need to be able to interpret the breakdown of those fertilizer figures. So the first thing that we're going to do is we're going to take one bag, right? One bag of fertilizer, 150 kilo bag of CAN, and we need to figure out how many kilograms of nitrogen is contained in that 50 kilo bag, right? So if it is 27% nitrogen, 27% of a 50 kilo bag is 13.5 kilograms of nitrogen. So the handiest way to work that out, whatever is the percentage, so that 27% nitrogen, if you just divide that by 2, it will tell you how many kilograms of nitrogen there is in the bag. The reason being basically is because if we were to work out a percentage, we're working it out of 100, right? So 27% nitrogen is 27 out of 100, but this is a 50 kilo bag. So 100 divided by 2 gives us 50 kilos. 27 divided by 2 gives us 13.5 kilos. So it's just a little shortcut. All you have to do, take that percentage and divide it by 2 to figure out how many kilograms are in each 50 kilo bag. So same with 150 kilo bag of urea. We take that, so urea we know is 46% nitrogen. Sorry, that should be 46% nitrogen. So what do? We take that 46%, divide it by 2, and that tells us that we have 23 kilograms of nitrogen per 50 kilo bag of urea. The same applies then when we go and look at our compounds. So we have 150 kilo bag of 18612, and all we have to do is divide each of those percentages by 2. And that tells us that we have, right, so 18 divided by 2, first of all, is 9. So we have 9 kilograms of N. 6 divided by 2 is 3 kilos of phosphorus. And 12 divided by 2 is 6 kilograms of K, or potassium. 150 kilo bag of 0730, the exact same principle applies. So 0 divided by 2 is still 0 kgs of N. 7 divided by 2 is 3.5 kgs of P. And 30 divided by 2 is 15 kgs of K. So you get the idea now. And then in terms of 16% superphosphate, okay, there is 0 nitrogen in it. It's 16% P, so that means there's 8 kgs of P, and there is 0 kgs of K. So that just tells us how to work out per 50 kilo bag of fertilizer, how many kgs of nitrogen there is. So the next thing then we're going to look at is how to work out what fertilizer would help us to address our nutrient requirements. So I've just come up with a vague figure, okay? I haven't pulled this from the assignment. This is just an example, all right? So if we have a grazing ground with a requirement of 6,485 kgs of nitrogen and 653 kgs of phosphorus, all right? If we were trying to only use one fertilizer product, for example, to address that requirement, we can just look at the ratio of nitrogen to phosphorus. So in this scenario, we can see that we need just about 10 times more nitrogen than phosphorus in our fertilizer. So 6,485 is just about 10 times more than 653. So what we can do is we can come and have a look at the breakdown of our fertilizers and see, is there any of those that have a ratio of 1:10 in terms of phosphorus and nitrogen? The reason that we're not worrying too much about potassium here, or K, is because there are different cross-compliance rules for nitrogen and phosphorus than there is for potassium. So the spreading period only applies to nitrogen and phosphorus. You can spread potash or potassium at any time of the year. And also there is no actual limit in terms of how much potassium you are legally allowed to spread. So we don't need to worry too much about that in terms of our cross compliance. So that's why we're not worrying about that too much here. But again, so just going back, we're looking for a ratio of 10:1. So if we look at these nitrogen heavy fertilizers, we can see that there's quite a few of them that are in and around that ratio of 10:1 for nitrogen to phosphorus, okay? So if we just look a little bit more closely, we see that we're looking, right, so the likes of the 27, 2.5, 5. That is a little bit heavier on the nitrogen than it is on phosphorus in terms of 10:1. And really, we're looking for a little bit lower than that. So the likes of the 24, 2.5, 10 might be a little bit more appropriate. So if we take one 50 kg bag of 27, 2.5, sorry, 24, my apologies, 24, 2.5, 10, and we need to work out how many kgs of NP and K are in that. We just divide by 2 to find out there is 12 kgs of N, 1.25 kgs of P, and 5 kgs of K. All right. So 150 kilo bag of 24, 2.5, 10 is going to give us 12 kilograms of nitrogen and 1.25 kilograms of P. So hopefully so far that is all okay for everybody. The next thing that we are going to do is we need to find out, okay, if 150 kilo bag is contributing, we'll just concentrate on nitrogen for the time being, it's going to contribute 12 kilograms of nitrogen to this requirement. So then how many bags of this fertilizer are we going to need to hit 6,485? So how do we do that? Well, we take our 6,485 kgs and we divide that by 12. Okay, so divide it by the amount of kilograms per bag to find out how many bags we need. So I'll just open up my calculator here. So 6,485 divided by 12 equals 540. 50 kilo bags. Okay, that's how many bags we require. Okay, 540 times, so we are going to need 540 50 kilo bags in order to meet that requirement of 6,485 kilos. So the next thing we are going to do is, remember, if we just click back to our assignment, we know that we need to figure it out in terms of tons of fertilizer as opposed to number of bags. So if we need 540 bags and there is 50 kilos per bag, we just come back and multiply this by 50, and that tells us that we will need 27.020 tons of fertilizer in the form of 24, 2.5, 10 to hit our nitrogen requirement. Okay. Hopefully that has all made sense so far. So the first thing, just to go back through it very, very quickly, what we first did was we tried to pick out a fertilizer product that had the correct ratio of nitrogen is phosphorus to meet our requirements. We worked out how many kilograms of nitrogen and phosphorus there would be per 50 kilo bag of that fertilizer. We then worked out how many of those bags we would need to hit our nitrogen requirement. And we worked out then how many tons of fertilizer that were required by multiplying the number of bags we needed by how many kgs of fertilizer there are per bag. So I hope that's all clear. The last thing that we need to do here is to double check. So remember, we only did this calculation based on our nitrogen. So we now need to double check that if we are to spread 540 50 kilo bags of 24, 2.5, 10, we will also be hitting our phosphorus requirement. So how do we do that? The exact same process as what we have done here, but with our phosphorus figures. So what do? We take 653 kgs of phosphorus, divide it by 1.25. Get our calculator. 653 divided by 1.25 equals 522 50-kilo bags. So what we can see here is that we are quite close in terms of meeting our phosphorus and our nitrogen requirement with that fertilizer. However, we always should be bearing in mind what our limitations are in terms of what we are allowed to spread. If we spread 540 50-kilo bags of 24 2.5 10, right? So we know one bag has 1.25 kgs of phosphorus, and if we multiply that by 540 bags, we can see that we are gone over our requirement of 653 kilograms of phosphorus. Okay, so we need to make sure that we are not exceeding that. So in this scenario, what is our best option? Instead of spreading 540 50-kilo bags of 24 2.5 10, we can come in instead and spread 522 bags. So that 522 times 50 gives us 26.1 tons of fertilizer in the form of 24 2.5 10, okay, instead of this, if that makes sense. So now I know that this is a lot to follow, but once you get the first one done, the rest of them will be a lot more straightforward after that, and we will do another example after this. Okay, so again, what did we do? We figured out what fertilizer was best suited to the ratio of nitrogen to phosphorus. We figured out the nutrients contained in one bag by dividing the percentages by 2. Then what we did was we divided the amount of nitrogen contained in one bag. We divided that into the total nitrogen we require to figure out how many bags we need to meet our nitrogen requirement. We then converted that into tons by multiplying it by 50, and that gave us 27 tons. Then to double check that we weren't exceeding our phosphorus, we divided 1.25 kilograms of phosphorus into 653 to find out how many bags would be required to meet the phosphorus requirement. And that told us that 522 bags was sufficient to hit our phosphorus requirement. And therefore, by spreading 540 bags, we will be exceeding that phosphorus requirement, which we don't want to do. So instead, what we want to do is we're going to stick with our 522 bags with 50 kgs of fertilizer per bag, and that's given us 26.1 tons of fertilizer. So how short are we on our nitrogen now? If our nitrogen needed 540 bags, but we're now only spreading 522 bags, how do we work out how short we are in terms of our nitrogen requirement? Okay, well, we know every bag, 12 kilograms of nitrogen, and we're now spreading 522 bags. So how much nitrogen is being spread? Is 6,264 kgs of nitrogen. All right, so we're just over 200 kgs short of our requirement. So 6485 minus 6264 equals 221 kilograms of nitrogen short. So in that scenario, what I would do is I would come into my document, okay? So we'll just say, for example, that these are the example figures that we are using, which is our 6485 and our 653. The chemical fertilizer we are recommending is 24, 2.5, 24, 2.5, 10. And the tons of fertilizer that we are currently spreading is going to be 26.1 tons. Now, in the scenario, we are slightly short on our nitrogen. I wouldn't worry too much about that for the time being, because we also need to ensure that we are not exceeding our 17.5 tons of chemical nitrogen. So if, for example, we proceed and fill in our grazing and reseed, our first cut and grazing, second cut and grazing, winter wheat and maize, we will need to add up the totals for how much nitrogen has been spread. So far we have spread 6,264 kilograms of nitrogen. We just worked that out. Okay, so we're allowed spread 17.5 tons of nitrogen altogether. We've just spread 6.264. So we now have 11 tons of nitrogen remaining to be divided across the rest of the ground. All right, so if we apply nitrogen to the rest of the ground and we find that we have a little bit left in our allowance, then we can always go back here and we can apply a small amount of CAN or urea to bulk up that nitrogen, that 200 kilograms of nitrogen that we are short. But we are pretty close to our requirement there, and we want to make sure that we do not go over our exceedance. I know that there is a lot to take in terms of the calculations there. So, feel free to go over it a number of times, rewatch it to make sure that you are clear on what you are required to do. So we'll just do another very, very quick example just to run through the procedure in terms of how to work out your how to work out what fertilizers are recommended. So we'll just say, for argument's sake then, that we have ground that has a nitrogen requirement of 2,565 kgs of nitrogen and a requirement for 195 kgs of phosphorus. Okay, so that we'll just say that that's our requirement for the time being. So how are we going to approach this? Again, we are going to look at the breakdown of our nitrogen is to phosphorus ratio. We can see that it's over 10:1. So in that scenario, maybe we are going to go with 27, 2.5, 5. What we could also do is we could go with the likes of your 18, 6, 12 and then compensate with a little bit of CAN or urea to make up the difference, because we know that the ratio here is only 3:1 for nitrogen to phosphorus. So that will leave us short on our nitrogen if we spread 18, 6, 12. So don't be afraid to go in with maybe 2 types of fertilizer, but again, be reasonable. Don't be picking 4, 5, 6 different types of fertilizer to be spreading. Keep it within reason. 2 types of fertilizer should be plenty to reach your requirements. So we'll just say that we will go with 18, 6, 12 for argument's sake. So 18, 6, 12, what do we need to do? We need to divide that by 2 to figure out how many kgs of each nutrient there is per 50 kilo bag. So 18 divided by 2 is 9 kgs of nitrogen. There then 6 divided by 2, 3 kgs of phosphorus, and 12 divided by 2 is 6 kgs of K per 50 kilo bag of fertilizer. Okay, so that's step 1. The next thing now we need to remember is, with that ratio, if we spread a lot of 18612, are we more likely to go over our nitrogen requirement or our phosphorus requirement first? So think about the ratio of nitrogen to phosphorus. There's 3 times more nitrogen than phosphorus in this fertilizer, but the ratio that we are looking for our requirements is over 10:1. There's over 10 times more nitrogen needed than phosphorus. So that means that if we spread a lot of 18612, we will exceed our phosphorus requirement first. So therefore, when we are doing our calculation, we will work off of our phosphorus to figure out how many bags of 18612 we can spread before we go over our limit. So if each bag, so if we need 195 kilograms of phosphorus, and each bag contains 3 kilograms of phosphorus, so 195 divided by 3 will tell us how many 50 kilo bags we need. Sorry, I've put that in wrong. 195 divided by 3 tells us that we will need 65 50 kg bags of 18612 to hit our phosphorus requirement. So what is that? 65 multiplied by 50 equals 3,250 tons. Sorry, apologies. That is 3,250 kgs of fertilizer, which equals 3.25 tons of 18612. So that is our our phosphorus requirement looked after. So now we need to go back and figure out how much nitrogen have we now spread. So we have spread 65 bags, and each bag contains how many kilograms of nitrogen? 9 kilograms of nitrogen. So 65 multiplied by 9 tells us that we have spread 585 kilograms of nitrogen. So we have a big remainder of nitrogen requirement left. So 2565 minus that 585 means that we still have another 1,980 kilograms of nitrogen to make up. So up here, we were only a couple of 100 kilograms of nitrogen short, okay? So we kind of let that lie, but being 2 tons of nitrogen short is obviously a lot. So we're going to go in and we're going to try and make some of that up. So what are we going to do? We're going to pick a fertilizer that is purely nitrogen. So we'll take the likes of our urea, okay? Granular urea, 46% nitrogen. So urea, 46% nitrogen. So one bag contains 23 kilograms of nitrogen. So how many bags of urea do we need? 1980 divided by 23 into our calculator, divided by 23 equals 86 bags of urea. So 86 times 50 is 4,300 kgs or 4.3 tons of urea. So in that scenario, we have now spread 3.25 tons of 18612 and 4.3 tons of urea. And the combination of those two fertilizers should have addressed our requirement for nitrogen and for phosphorus. So now again, always thinking about what our limitations are. So in the assignment, we know that our limitations are 17.5 tons of chemical nitrogen and 1.5 tons of chemical phosphorus. So apologies, sorry, I've just pressed the wrong thing. So we come back here. Our 17.5 tons of nitrogen is our maximum. So up here we spread 6.2 tons of nitrogen. And then down here, how much nitrogen did we spread? Well, we spread 500. So I'm taking these away from the 17.5. 17.5 minus 6.264 minus our 0.585 from our 18,612. All right, and minus our 1.980 from our urea as well. Okay, so that's just a quick example. Hopefully I've done that right. 17.5 minus 6.264 is 11. Okay, yeah, so there was a mistake there somewhere. Okay, so 17.5 is the maximum nitrogen we are allowed to spread, minus 6.264 tons of nitrogen up here, minus 0.585 tons of nitrogen in our 18,612, and also then minus our 1.98 tons of nitrogen in our urea. So we now have 8.6 tons of nitrogen remaining before we hit our limits. And you can do the exact same then for the phosphorus as well. So in that scenario, we spread exactly the amount of phosphorus that we needed. So we have spread, so we have 1.5 ton allowance, we've spread 0.653. And then down here, we've also spread exactly the amount of phosphorus required. So we minus 0.195. So we have 0.65 tons of phosphorus remaining that we will be allowed to spread. All right. So I am hoping that that is understandable for you. Again, what would I do in that scenario then? We come back in, so we'll just say that that's gone. Okay, so just deleting them out from the first one. So how would we fill that in? Okay, well, our total nitrogen requirement was 2565. Our total phosphorus requirement was 195. The chemical fertilizer products we used was 18,612 and urea. And then the tons of fertilizer allowed, we went with 3.25 tons of 18,612, making sure that it matches up with the fertilizer across from it. And then in terms of the urea, we went with 4.3 tons of urea. So the most important thing that we need to do is always double check that we are not going over our limitations. Have a good look through the fertilizer to save yourself time, because there are so many products available. By trying to find one that has a close enough ratio can help. But always make sure that if you are well short of your requirements, that you come in with another fertilizer to bring you close enough to what is required. So even if we knew that we had another 1,980 kilograms of nitrogen were left required before we spread the urea, even if you were to come in with 1,800 or 1,600, just make sure that you're not leaving a massive amount missing from that nitrogen. And double check then, when we have all of this completed, we need to make sure that the nitrogen and phosphorus contained in all of the fertilizers that we are spreading do not exceed our maximums up here, because that is what's going to be most important in terms of our cross compliance. So again, just highlighting what you need to do here, make sure, come into your table up here, pull down your nitrogen and your phosphorus requirements. Down here, pop them into these two boxes, and then work out what fertilizer products you want to use and how many tons is allowed. So there is a good bit of work involved in that section. It is worth the most marks on the assignment. So do put the time into it. And like I said, once you have the first one or two done, you will fly through the last ones. You will fly through the last ones, okay? So I hope that is okay. Feel free, as I said the last day, to contact me, MEABH full stop OHAGAN at teagasc.ie if you have any questions. And so I hope that was helpful. So thank you very much, everybody, and good luck with the assignment.